Hi, everybody. Good evening, everyone. Thank you so much for joining us. My name is Mark Gillette, and I'm a NASA JPL Solar System Ambassador. I'd like to again welcome you so much tonight to my event entitled Moons of Our Solar System. For those who don't know me, I am a NASA JPL Solar System Ambassador, and that's kind of a fancy way of saying I'm a volunteer. I was chosen by JPL about 2 years ago to do presentations for NASA. And I generally go out into the community, different libraries, and I do a variety of different topics regarding NASA and our solar system. So over the last several months, I've been doing presentations here on YouTube, and I will be continuing to do those over the next several months. So if I can ask you to please subscribe to my YouTube channel, I would highly appreciate it. The next two events I have coming up are on Sunday, November the 22nd, where I will be talking about galaxies, and Sunday, December the 20th, where I will be talking about rockets. Both of these times, 8 p.m. or Eastern Time, so for those that live in different time zones, adjust as needed. I'd like to give a special shout out to several libraries around the country, including the Winfield Library in Illinois. Hi, Dawn, I know you're attending tonight. The S.W. Smith Memorial Public Library in Pennsylvania. The Bangor Public Library in Pennsylvania. The Cooper Siegel Community Library in Pennsylvania. The Gates Public Library in New York, the Prairie Trails Library District in Illinois, the Prince George's County Memorial Library System in Maryland, the Wilhelmina Public Library in Oregon, the Lake Dallas Public Library in Texas, the Technology Engagement Center, part of the Rutherford County Library System in Tennessee, the Solano County Library in California. Hi, Jennifer. The Cudahy Family Library in Wisconsin. The Moores Memorial Library in Pennsylvania. The Ottawa-Prattsville Public Library in Alabama. And last but not least, the Geauga County Public Library in Ohio. So again, thank you so much for joining us tonight. I did say us because I have found it to be very challenging to both monitor the live chat box where you can get involved and ask questions throughout the presentation and do my presentation at the same time. So I have recruited the help of an assistant, and my assistant is my husband. His name is Spencer, and he is going to shout out. All right, so he's going to keep track of the chat box, and if you have any questions, if you can please put your questions in the chat box, and he's going to be letting me know that those questions are there so that I can be addressing them as they come through. If you could please do me a really big favor and tell me how you heard about tonight's presentation, and tell me where you're from, and you can just type that information in the chat box and I would appreciate it. One more thing I'd like you to think about typing in the chat box is, as I think about my winter series starting in January, I'd like to do some presentations that you all might be interested in me doing. So if there's a particular topic that you would like to see me do a presentation on, please put that in the chat box and I will certainly consider putting something together for it if I feel like I can do so. So, here's tonight's agenda. We're going to take a look at defining a moon. We will be looking at moons from Europa to Charon. We will be talking very briefly about our own moon and NASA's Artemis program. We will speak briefly about what's called exomoons, and at the very end of the presentation, hopefully have a few minutes for Q&A that weren't addressed throughout the presentation. On the right-hand side of your screen, you see a picture that I took of the Earth, of the moon, which is about 250,000 miles from Earth on average. All right, I do want to adjust what you are looking at, and then we're going to get started. I'm going to put myself down here in the corner, and I'm going to increase the size of the screen, and we will get started. All right. On your screen, you see just a few of the moons within our solar system, with the Earth down on the right-hand corner for a scale, so you can compare the size of the different moons within our solar system. A moon is a body that orbits a larger object, such as a planet or even an asteroid, which in turn orbits stars. Moons are also called natural satellites. Now, there are more than 200 moons in our solar system, and it is hard to have an exact number due to limitations in cameras and telescopes. They come in many different sizes, shapes, and types, but they are generally solid bodies and have few of them have atmospheres. There are two broad categories of moons, regular and irregular. Here are the characteristics of regular moons. Number one, they have what's called prograde motion, which means that the moon moves in the same direction as the planet. Number two, a regular moon has what's called little orbital inclination, which means that the tilt is very similar to that of the planet. Number three, there is very little eccentricity or deviation from a perfect circle. And number four, it is believed that these moons have formed in the orbit about their planet. So again, those are all characteristics of a regular moon. How about the other type, an irregular moon? They often have what's called retrograde motion, which is direction opposite the rotation of the planet. I'll be mentioning one of these later in the presentation tonight. Number two, an inclined orbit. All right. Number three, an eccentric orbit. And number four, that they have often been captured by their host planet. And I'll be speaking about Mars shortly, and both of the moons of Mars are considered captured. Most large moons in our solar system are what's called tidally locked. And I'm wondering if anyone attending knows what tidally locked means. If you know what it means, can you type it in the chat box? And I'll check with Spencer to see if anyone comes up with the right answer. So let me repeat that again. Most large moons in our solar system are tidally locked. What does tidally locked mean? Spencer, anyone coming up with any answers?
No. You want to repeat it again?
Yep, I'll repeat it again. Most large moons in our solar system are tidally locked. What does that mean? What does it mean to be tidally locked? I'll give you just another moment or two to see if anyone can come up with it. Nothing's coming through in the chat box.
Frank says I have no idea.
Okay. Tidally locked basically means that the same face of the moon is always shown on the planet. So for example, if you walk out your door when there's a partial or a full moon, we always see the same side of the moon. We never see the far side or the dark side. All right, and that's what tidally locked means. And most of the large moons within our solar system are indeed tidally locked. If you were on the planets looking at the moons, you would always see the same face. Okay? All right. Well, that's a little information about moons in general. Speaking about the far side of the moon, there are cows on the moon, yes, but only on the far side. Share a couple pictures that I've taken. On the left-hand side of your screen is another picture that I took of our moon with a basic telescope. And over on the right-hand side of the screen you can see the big white blob is planet Jupiter, and you see 4 little white dots here, 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 and there. And these are what's called the Galatian moons. They're titled the Galatian moons because they were discovered by Galileo. All right, and we'll be talking about the Galatian moons when we talk about Jupiter a little bit later. And you don't need a telescope to see the Galatian moons unless you live in an area where your sky is completely light polluted. You can go out when Saturn's up, and you can, if you look very carefully, see the Galatian moons. Actually, you'll probably need like a set of binoculars or a very inexpensive telescope to see them. All right, so we're going to start from the inner part of the solar system and work our way out. And I'm skipping over planet Mercury and planet Venus for a very simple reason, and that is because they have no moons. We're going to be talking about the Earth's moon at the very end of the presentation, so we're going to go and start with Mars. And Mars has 2 moons, all right? And what I'm going to be doing is I'm going to be going to NASA's solar system website, and it has information about each of the planets and the moons of those planets. So if I scroll down here, you can see the 2 moons of Mars, Phobos and Deimos. Okay?
Frank wants to know what are the moons made out of.
So the moons, depending on where they are in the solar system, Frank, generally they're made out of some type of a rock, and many of them will contain ice as we go further out into the solar system. But generally there's some type of rock. All right. Now, during tonight's presentation, I'm also going to be using what I've used before, and that's what's called NASA Eyes. NASA Eyes is a wonderful program that allows us to take a look at our solar system. You can access NASA Eyes. I'm getting a high CPU usage detected, so I'm hoping I'm not going to be running into any problems tonight with technology like I did last time, so let me know if it looks like there's any issues. You can go to NASA's Solar System Exploration website, and you can access NASA Eyes by clicking on Solar System. I like to use the version that I've actually downloaded to my computer. Just do a Google search for NASA Eyes, and you download just some very basic software, and then you get access to some really cool stuff. So for those of you who have joined me in the past, you've seen this. For those, this is your first time, you're going to definitely want to take a look at NASA Eyes. All right, so here we have our solar system. We've got the sun. We're not talking about Mercury. We're not talking about Venus. Neither have moons. We'll come back and talk about the Earth later. We're going to start with planet Mars. Okay, so here is planet Mars. I'm going to go over here on the right hand side and turn the light on so we can see it better. So here's planet Mars right here. North Pole is here. South Pole is right there. Here's the Valley Marinaris, and here is the largest mountain in our solar system. And so let's back up just a little bit and let's find Phobos. This is our first moon that we're going to take a look at. So let me go ahead and scroll around here so that you can get a quick little glimpse of Phobos. Phobos is the larger of Mars's 2 moons. It's larger, but it's really not that big. It's roughly only about 17 by 14 miles, so it's not a very big moon. It orbits Mars about 3 times every day. It's closer to its host planet, that is Mars, than any other moon in our solar system. It's orbiting closer and closer to Mars every single year. It's actually orbiting about 6 feet closer every 100 years. Now, you might think 6 feet in 100 years is not very much, but you have to look at it on an astronomical timeline. And when you look at it on an astronomical timeline, that means that somewhere in the next 30 to 50 million years, one of two things is predicted to happen. Phobos will either crash into Mars because it's getting closer and closer to Mars, or it will break up due to the gravity of Mars's effect on it, and it will form a ring system, much like Saturn has, around planet Mars. That's pretty cool. As you can see, it's got a lot of potholes on it, and that is because it's been beaten many times by meteors. It is, along with the other one that we will be speaking of in a moment, Deimos, considered to be a captured asteroid. Okay, and that's really important to know. When we talk about our moon, it's not a captured asteroid. We'll look at a theory or two as to how our moon formed, but these are considered captured asteroids. All right. Let's go ahead and go to the other moon of Mars, Deimos. This is the smaller of Mars's 2 moons. Go ahead and take a look around it. It's only about 9 miles by 7 miles wide. It orbits Mars about every 30 hours. It also has signs of meteor impacts. You can see them here. We can scroll in a little bit. You can see them there. Its orbit is actually slowly getting further and further away from Mars. So it's doing the opposite of Phobos. So it is expected to eventually escape Mars's gravity, leaving Mars with just that one other moon until it crashes into Mars, which will eventually potentially leave Mars with no moons at all. All right, how are we doing in the chat box? Any questions?
Not right now.
All right, very good. Hopefully everyone is enjoying this. We're going to go ahead and move on to the next planet. And we're going to move on and talk about the moons of Jupiter. I spoke earlier about the 4 major moons, or what's often called the Galatian moons, because Galileo discovered them. Those are Io, Europa, Ganymede, and Callisto. Now, Jupiter actually has 53 named moons and another 26 that are awaiting official names, for a total of 79 total moons. And if we scroll down here a little bit, you can see a list of all of the moons, the known moons of Jupiter. Again, check this out on NASA's website, solarsystem.nasa.gov. Okay, I'll load some more. These are all the known moons of Jupiter. Okay, certainly, we're not going to talk about all these. I'm only going to talk about the 4 Galatian moons right now. All right. So, I'm going to go back to NASA Eyes. We're going to go directly to planet Jupiter. Okay, planet Jupiter. All right, here's planet Jupiter. Let's see if we can get Jupiter to be right side up. Alrighty. There we go. There's Jupiter right side up. Let's go ahead and scroll out so that we can take a look at the moons. Turn it on its side. And here are the 4 Galatian moons: Io, Europa, Ganymede, and Callisto. So let's start with the closest large moon, and that's Io. All right, let's take a spin around Io. To me, it kind of looks like a spoiled, round pizza. But that's actually different colors of sulfur that we see on the surface of Io. Io is the most volcanically active body in our solar system. It is a bit larger than our own moon, and it is the 3rd largest of Jupiter's moons. Io's surface is covered by sulfur, as I mentioned earlier. Jupiter's immense gravity causes tidal heating. Now, I mentioned being tidally locked earlier. And again, tidally locked means that the same side of the moon is always facing the planet. And indeed, this particular moon, Io, is tidally locked. But now we're talking about tidal heating. All right, what is tidal heating? Let's go back and pull Jupiter into the picture here. And you can see that Io is relatively close to Jupiter. Jupiter is so large. It is the largest planet in our solar system. It is twice the size of all of the other planets put together, which means it has a tremendous gravity field, extremely powerful. And so as Io orbits Jupiter and also interacts with the largest moon in our solar system, Ganymede, and Europa, what it does is it pulls Io. It pulls like this. And what that does is it creates friction and heat. All right? And that friction and heat has to be released somehow, and it's often on Io released through volcanoes.
No, you had a question about something else regarding Earth being hit by asteroids.
Well, what I may do in the future, if that's a topic that you'd like me to address, asteroids hitting Earth, I can probably put together a presentation about that. Some of you may be aware on that very subject that just back a few days ago, NASA landed a probe on Bennu, which is an asteroid, collected a sample of regolith or soil and sand on the top of the asteroid, and will be returning that to Earth in 2023. So maybe that's a topic I can talk about if you'd like me to in one of my next presentations.
And what about black holes? You're going to talk about black holes?
That might be something also that I can put together a presentation about black holes in the future. All right. So let's go back to Io. So again, the most volcanically active moon in our solar system, and one of the reasons for that is because of the gravitational pull of some of the other major moons, and of course Jupiter kind of pulling it and stretching it, which creates internal heat. That heat has to be released, and it's released through volcanoes. So Io is a pretty neat moon to take a look at. All right, let's back up and go on to another moon. We're going to take a look at Europa. Now, I've spoke of Europa in previous presentations before. It's a really exciting moon. And it's a really exciting moon because it has the potential to host life. It has all of the ingredients needed, as scientists believe they are needed, to host life. We have not yet found life on Europa because of limited budgets and limited spacecraft that go there, but hopefully someday in the future, NASA or some other space agency will be sending some type of a lander or a probe to Europa to see what's going on below what you're looking at here. And what you're looking at here is basically liquid ice. I'm sorry, frozen ice. All right. So the surface is mostly water ice. It is believed that there is a subsurface water ocean which contains about twice the amount of water as we have here on Earth. So this moon has a lot of water on it. It's slightly smaller than Earth's moon. Its orbit is eccentric. It's not a perfect circle. It's more of an oval. And what I can do here is let's see if I can go back here, and we can bring Jupiter back in. Okay. And we can kind of take a look at the orbit. And if we look at the orbit, it may not show it extremely well, but Europa's orbit is not completely circular. Okay, which means then, because it's somewhat of an oval, that at sometimes it will be closer to Jupiter than at other times, which again helps to create that tidal heating that I talked about on Io. And that tidal heating is really important because it is believed that there might be some type of hydrothermal vents underneath the liquid or the solid ice that covers the moon, and if there's heat internal to the hydrothermal vents, it's heating up the water in that ocean, which then means that there's a liquid water ocean, which means that it could potentially host life. Okay, so it is also tidally locked to Jupiter. So again, the same side is always facing Jupiter. And I want to go back here and I want to show you a little video on Europa. This video, I believe, is just here we go. It's just 4 minutes long, so let's take a look at this.
The search for life beyond Earth begins with understanding life on our home planet. And that story, the story of life on Earth, may have begun in our oceans. And that's because, of course, if we've learned anything about life on Earth, it's that where you find the liquid water, you generally find life. So, what if I told you that there is an ocean out there beyond Earth? An ocean in our solar system that has been in existence for billions of years. It's an ocean that is perhaps 10 times as deep as Earth's ocean. It's an ocean that is global and may contain 2 to 3 times the volume of all the liquid water on Earth. It's an ocean that exists beneath the icy shell of Jupiter's moon, Europa. So how do we think we know that Europa's ocean exists? Well, it's a combination of using telescopes on the ground and having spacecraft that have flown by Europa and collected data about the surface, about the interior structure, and about the magnetic field around Europa. And the combination of those data sets leads us to a high degree of confidence that this global liquid water H2O ocean is there today, and it's been there for much of the history of the solar system. We used to think that in order for a world to be habitable, you had to be at just the right distance from the sun or whatever you're, have a liquid water ocean on the surface. Now, along with liquid water, life as we know it needs 2 other keystones. The first is the building blocks for life, the stuff you find in rocks. And the second is some form of energy to help power life. And here's where Europa is a real game changer. It is far, far out from the sun, and yet it's got this liquid water ocean. And the reason that Europa has liquid water is because it's orbiting Jupiter, and the tidal tug and pull causes Europa to flex up and down, and all of that tidal energy turns into mechanical energy, which turns into friction and heat that helps maintain this liquid water ocean beneath an icy shell. Along with helping maintain liquid water, we think that tidal energy may also allow that ocean to interact with rocks on Europa's seafloor. And it may even give rise to things like hydrothermal vents, which could help provide not just the building blocks for life, but also the energy for life. The question of whether or not life exists beyond Earth, the question of whether or not biology works beyond our home planet, is one of humanity's oldest and yet unanswered questions. And for the first time in the history of humanity, we have the tools and technology and capability to potentially answer this question. And we know where to go to find it. Jupiter's ocean world, Europa.
So that's pretty exciting stuff. Now NASA is putting together a new mission. It's going to be called the Europa Lander, and to find out more about that new NASA's mission, you can go to Europa, EUROPA.nasa.gov. Okay, now let's go on to our next moon, and we will be going on to Ganymede. And let's pull up Ganymede here. The first thing that we want to say about Ganymede is that Ganymede is the largest moon in our solar system. There's a quick look at Ganymede. It is actually larger than the planet Mercury. It is the only known moon to have its own internally generated magnetic field. And, in fact, it has a very, very thin oxygen atmosphere, but it is far too thin to support life. Okay, anything coming up in the chat box?
Not right now.
All right, very good. Then let's go on and let's take a look at the fourth moon that I'd like to speak of in orbit around Jupiter, and that is Callisto. All right, there's Callisto. Okay, take a quick look around Callisto. Again, you can always go back on your own time and do more investigation in NASA Eyes. If you click on the eye down here in the corner, it will give you all kinds of information regarding anything and everything that you're looking at within NASA Eyes. Callisto is the most heavily cratered object in our solar system. The bright areas that you're looking at are mostly ice, and the darker patches are areas where the ice has eroded. It may have a salty ocean beneath its icy surface, but that is still inconclusive. Okay, so Callisto, the largest moon in our solar system. All right, now let's move on and move to Saturn. And let's take a look at the moons of Saturn. There are 82, 53 are confirmed and named. Another 29 are awaiting confirmation and official naming. So here you can see the known moons of Saturn. Or load some more. Okay, there they are. So I'm going to be talking mainly about just a couple of them. Saturn's moons range in size from larger than the planet Mercury, Titan, to as small as a sports arena. All right, so let's go back to NASA eyes. Let's go to Saturn. All right, beautiful Saturn right here. Scroll out just a little bit. All right, and right now I have the major moons of Saturn turned on. I'm going to turn them off. You see there's Saturn all by itself. We'll turn on the major moons. I'll be speaking about Mimas and Enceladus and Titan. But I also want to turn on the minor moons so you can see them as well. And there you go, you can see that they're popping up. Okay, so let me turn the minor moons off. Let me find the first one that I'd like to speak about, and that is Mimas. And I'll take you around there real quick. You see it's heavily cratered, and you can see this really large crater right here. Okay, this is the innermost of Saturn's major moons, Mimas. The most distinguishing feature is a giant impact crater named Herschel after the moon's discoverer, William Herschel. For those that are a big fan of Star Wars, this should look familiar because it looks like the Death Star from that movie series. This moon, Mimas, is tidally locked with Saturn, so the same side is always facing planet Saturn. Okay, that's a little bit about that moon.
So you have a question from Liam, age 9. Does space go on forever?
That's a very, very, very good question that we do not know the answer to. Scientists simply do not know if space goes on and on forever, if it's infinite.
Isn't the universe expanding?
The universe is expanding. It is not what scientists expected. And that was only discovered by Hubble. That name should sound familiar to you. Back in the early part of the 1900s, he was the one, I believe he was the one that discovered that the universe is actually expanding. But unfortunately, we do not know if the universe is infinite. There is some theories out there that say that we live in what's called parallel universes, that we live in one universe and there may be lots of other universes out there, but there's no way for us to conclude that at this time, so it's only a theory.
Is that a future topic?
That could be a future topic if that's something that you would like me to do a presentation on. And again, if anything pops into your head during the presentation and you'd like me to consider putting a presentation together about it, please let me know by putting it in the chat box. All right, let's go to Enceladus. Enceladus is a really another neat opportunity for NASA because it is theorized that it could host life. All right. Again, we have not found life on Enceladus, but it has the right ingredients. So here's a quick look at Enceladus. And I'm going to leave it right here because I want you to look at what you see right here. I'll speak about these in just a minute. All right, so NASA's Cassini spacecraft in 2005 discovered that icy water particles and gas gush from the moon's surface at approximately 800 miles per hour. And that's what you're looking at. Okay, gas and water being expelled from the planet. And I'm going to scroll in some more so you can get a really good look at it. And the animation, the people that wrote this software did a really cool job because you can actually see it looks real, like it's really gushing from the moon itself. A lot of that gushing water returns to the surface of Enceladus as snow, which keeps the moon a very bright white. It has a liquid water ocean beneath its frozen shell. It reflects almost all of the sunlight that strikes it. The surface temperature is extremely cold. It's roughly about 330 degrees below 0 Fahrenheit. Okay? And like the others I've spoke of, it's tightly locked with Saturn. Okay? So with the tugging of the other moons around Saturn, and its elliptical rather than a circular orbit, Enceladus is subject to tidal heating, as we've talked of before. All right, and that tidal heating can create liquid water. Okay, you can see that there are some fractures on the surface. Right here, you can see the fractures everywhere. And these are believed to be due to the tidal heating, hot water coming up to the surface, splitting the ice, and freezing, forming these lines. Okay, so I've got a short little video. No, actually, I'm showing that to you for the next moon. We need to go on the Titan before I show you that video. So here's our next moon that we're going to take a look at. We're looking at moons of Saturn, and that's Titan. It's the biggest moon of Saturn. It's the second largest moon in our solar system. It has a very thick, hazy atmosphere, and that's what you're looking at here. Basically, you're looking at, well, gee, nothing. So I'm going to turn on the feature that allows us to see the actual surface. In other words, penetrating through that haze so that we can see what the actual moon looks like. And that's what that feature allows us to do right there. The temperature at the surface is roughly minus 289 degrees Fahrenheit. This is the only place other than the Earth in our solar system known to have liquids, methane and ethane. Okay. Triton's subsurface water could be a place that harbors life. Okay, and so let me go back here because I do have a short video that I want to show you about NASA's Cassini spacecraft that contained the European Space Agency's Huygens probe. And the Huygens probe separated from NASA's Cassini spacecraft and actually went down through Titan's atmosphere and landed on the surface of Titan. This was back in 2005. What I'm here is actual footage. All right, so that's pretty cool because, again, most of what you saw there was actual video footage taken from the Huygens lander that went down to the surface of Titan. So that's pretty cool. That was not animation. All right, we're going to move on to the planet Uranus. And here are some of the moons of Uranus. While most of the satellites orbiting other planets take their names from various mythologies, Uranus's moons are named for Shakespearean characters, along with a couple of the moons being named for characters from the works of Alexander Pope. Uranus has 27 known moons. Let's see here, and I will again take you right to NASA's website that has all kinds of information about the moons. So here are the moons of Uranus. All right. All of Uranus's inner moons appear to be roughly half water ice and half rock. The composition of the moons moons outside of the orbit of Oberon are likely captured asteroids. And that should ring a bell because that's what is believed Mars's moons are, captured asteroids. Okay, and if we go back to NASA eyes, we can go to Uranus. We're gonna back up. Right now, the major moons of Uranus are turned on. There you can see them, but let me turn on the minor moons as well, and you're going to see something pretty interesting happen. Look at all those minor moons that are popping up that are relatively close in orbit around Uranus. Okay. All right. And because of our time closing in, I'll take us now off to Neptune. Okay.
So someone asked, why is Uranus sideways?
So it is believed that Uranus, which is at a 98-degree tilt, was hit by another very, very large object in the solar system, causing it to move over kind of and spin on its side. Same thing with the Earth. The Earth is tilted at about 23.5 degrees off of being vertical, I'm sorry. And it is believed that our Earth is tilted because the moon, another large object hit our planet, which threw material off of our planet, forming the moon, but because of that large body hitting the Earth, it caused it to tilt on its side.
That question is from Maggie.
Yes, Maggie. Oh, that question is from Maggie. So that's what's believed why Neptune is doing that very unusual thing that it's doing.
And the question is, how could Uranus been hit if it's made mostly of gas?
It is mostly of gas, but there is a small interior rocky core. Okay, it's not very big. Most of the planet, along with Jupiter, Neptune, and Saturn, are gas giants, but they do have a very small inner core. Okay, that's not gas. All right, so here are the moons of Neptune. Okay, again, we're not going to go through and talk about all these, but there is one that I do want to talk about, and that's Triton. Okay, so let's back up here, and let's find Triton. And here's Triton. Triton, not to be confused with Saturn's moon Titan, is the largest moon of Neptune. It is the only large moon in our solar system that orbits in the opposite direction of its planet's rotation, called a retrograde orbit. All right? So Triton orbits counterclockwise while Neptune orbits clockwise.
Why?
Why? I believe the answer is, though don't hold this to me, again, something hit because of something hitting it and causing it to spin in the opposite direction. Okay? Scientists believe that Triton is a captured Kuiper belt object. As we go out further into the solar system, when we get past Neptune, we get to what's called the Kuiper belt. And it is believed that Triton is a captured Kuiper belt object, which is tidally locked with Neptune. It has a thin atmosphere of mainly nitrogen and methane. Triton, Io, Venus, and Earth are the only known bodies in the solar system to be volcanically active. Triton, Io, Venus, and Earth. Okay? It is one of the coldest objects in our solar system at about minus 400 degrees Fahrenheit. Okay? And I do want to take us to dwarf planet Pluto. Dwarf planet Pluto. Here is dwarf planet Pluto. The NASA spacecraft New Horizons got awesome pictures of Pluto as it went by. So that's why we can see what we're seeing here. But I want to talk about one moon, and that is Charon.
And before you get to that, Maggie wants to know, if something hit Triton, would it stop spinning?
If something hit it, would it stop spinning?
Or would it spin
It could make it.
direction on its axis?
I think theoretically, I think it could cause it to spin in the opposite direction. It could cause it to spin faster. It could cause it to spin slower. Yeah.
So what's the moon we're getting to now?
So right now we're talking about Charon. This is a moon of Pluto. It's about,
How do you spell
well, yeah, so it's Charon, but it's pronounced Charon. All right? And so it's about half the size of the dwarf planet Pluto. Pluto and Charon are sometimes referred to as a double binary dwarf planet system. Okay? And Charon is tidally locked with Pluto. Okay, so kind of an unusual situation here when you have a moon that's almost half the size of the planet, or in this case, the dwarf planet. And that's why I wanted to mention Charon very quickly.
How many moons does Pluto have is the question from Maggie.
How many moons? Well, Pluto is so far away, and we have limited technology when it comes to cameras and telescopes that we probably have not discovered all of the moons of Pluto. And so there is one that's for sure, and that's Charon. There are 3 other confirmed moons, and those include Styx, Nix, Cerberus, and Hydra. Those are the known and confirmed moons of Pluto. Okay? All right. Last but not least, we need to take a look at our planet, our planet's moon.
Why is our planet's moon only called the moon?
That's a very good question, and one that I cannot answer. That's a very good question. But I will say that if you ever do, any of the young people that are attending, if you ever do a project on our moon, you always want to capitalize it. All of the other moons that we talked about, you have a lowercase m, but when you talk about our moon, you need to capitalize it, capital M-O-O-N. Okay, then that's how you can kind of distinguish between the two. There are a few theories on how we got our moon. The leading theory is when a large body about the size of Mars collided with Earth, ejecting a lot of material from our planet into orbit. Debris from the early Earth and the impacting body accumulated to form the moon about 4.5 billion years ago. Of course, we know that the moon is tightly locked with the Earth because whenever we see the moon, we always see the same face of the moon. Let me take you to...
While you do that, what moons are the scientists most excited about?
The moons that scientists are most excited about would include Europa around Jupiter, Enceladus around Saturn, Titan around Saturn. Those are probably the three most leading, interesting moons, and I say that because of their potential to host life. And so that's why scientists are most excited about those particular moons. Here is a quick little video that shows all of the Apollo landing sites from the late 1960s to the early 1970s. And you can see the patches on the right-hand side of your screen that light up. Here is the dates and the times when they landed and how long they stayed there. And you can see them pop up on the left-hand side. So I'll let you take just a moment to take a look at these landing sites. As you're looking at the last few here, as we are wrapping up our time, I do want to mention to you that NASA has plans to return to the moon. NASA is building a new rocket called the Space Launch System, the SLS, and the Orion Space Capsule, what the astronauts will fly in on top of that SLS rocket. A lot of testing has been done over the last several years, and the first Artemis 1 mission, and that's the name of the return to the moon, Artemis, the twin sister of Apollo, is scheduled for late next year, late 2021. There will be no astronauts on board, but the Space Launch System and the Orion capsule will go to the moon, orbit the moon several times, and return back to Earth. So on the left-hand side of your screen, you can see the official logo of the Artemis program. On the right-hand side of your screen, you can see the Space Launch System, the SLS rocket that's being built. And at the very top is the Orion Space Capsule. It is projected at this time that we will have the first woman and the next American man to land on the moon in the year 2024.
So
And-
Flora has a question. Maggie wants to know if something the size of Mars hit Earth, wouldn't there be a large crater somewhere?
Well, Maggie, I hate to tell you this, but if a large size body the size of a planet like Mars was to hit Earth, it would not be a good day. And I think I'll leave it at that. It would be very, 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 very bad. 65 million years ago, a relatively small asteroid hit the Earth, nowhere near the size of Mars, and it is theorized that it wiped out the dinosaurs. And so you're talking about something the size of a planet like Mars, it would not be a good day. But I don't lose any sleep over this because NASA and other space agencies keep a very close eye on these things, and there is nothing anytime in the near future that's projected to hit Earth, so don't worry about it.
Isn't that what they were trying to do with OSIRIS-REx?
They with the OSIRIS-REx space mission, which collected some samples from the asteroid Bennu a few days ago, they're just trying to learn more about asteroids so that if in the future it is determined that an asteroid is coming to hit Earth, that we can take some evasive maneuvers and do something and perhaps steer it away from the Earth to go somewhere else. So.
Is that the mission of Space Force? No one to know if you're going to talk about Space Force.
No, I will not be speaking about Space Force because that is another branch of the U.S. military, which is completely separate from NASA. And so I have no knowledge of the U.S. Space Force. I'm sorry. Last thing I want to bring to your attention is exomoons. What is an exoplanet? Anyone? And I know we're about at the end of our time here, but can anyone type in the chat box if you know what an exoplanet is?
Is this where I play the theme from Jeopardy?
Yes. Exoplanet. Anyone know what an exoplanet is? Da,
Exoplanet,
da, da.
exomoon.
Right now I'm asking for exoplanet. Da, 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 da. Anyone know what an exoplanet is? Dun, 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 dun. All right, an exoplanet is a planet outside of our solar system. We have 8 planets in our solar system. All right, we have some dwarf planets like Pluto. But if we find a planet orbiting another star somewhere out in the Milky Way, that's called an exoplanet. And over 4,000 exoplanets have been detected to date. We have all kinds of neat, cool instruments and spacecraft that are looking for exoplanets today. And so they're finding them all the time. So far, no exomoons, which would be basically, as we defined a moon earlier, a body orbiting a planet, have been detected. Why? Because they're so incredibly small. We don't have the technology to find moons orbiting exoplanets around other stars at this time. But I suspect that sometime in the future we will have some methods of determining if exoplanets have moons, and I'm thinking the answer is probably yes.
Are you going to be talking about exoplanets in the future?
I could. I absolutely could if that's something that you would like me to talk about.
And do you think there's oxygen in these exoplanets?
I would suspect that there probably is oxygen in the atmospheres of some of the exoplanets.
And why can't we find oxygen out in space? That's a question.
Why can't we find it out in space? Oxygen is a gas out in space that was created by the explosion of very, very large stars that form nebulas. And nebulas are the birthplace of brand new stars, which will also have planets forming around the new stars, and that's where the oxygen could be collected around those new planets. All right, well, I again ask you, if you haven't subscribed, please consider subscribing to my YouTube channel. Remind you, I've got 2 more YouTube live events planned for this year, 2020. Galaxy Quest, November 22nd, and 321 Liftoff on December 20th, 8 p.m. Eastern Time. Please join me if you can.
And you're having some planned for next year, too.
And so I will be putting together some new YouTube live events starting the winter season, starting in January. I'm probably thinking that for January, I want to do a presentation about the Mars Perseverance, formerly known as Mars 2020 rover, that will be landing on Mars February the 18th. It was launched from Cape Canaveral on June 30th, just a few months ago. And so it's going to be really, really exciting to see this new rover land in Jezero crater on the planet Mars. And so maybe I might put together a presentation about that rover for January.
Is that the rover you saw at JPL?
Yes, and I actually had the opportunity to see this rover being built, and so I've got some pictures I can share with you of that process. All right, does anyone else have any other questions that you would like me to address before we call it an evening?
Someone mentioning they want you to present about black holes. I think you answered the question about oxygen in space. They exist.
Yes,
in nebulas.
Yes.
You can't breathe in space.
No, you can't breathe in space. That oxygen will need to be part of the formation of the planet so that the planet pulls in the oxygen and holds it there. All right, any other questions?
I think that's it. Christine Bass just says, thank you for the great presentation. My son and the rest of the family really enjoyed it.
All right, very
Everyone
good.
else enjoyed it.
All right, I can't thank you enough for taking your time to join me tonight. I hope that you've enjoyed it, and I hope that you mark your calendar for those upcoming YouTube live events. If you can't, come back to my YouTube channel 24 hours after the event, and you can see it archived there. But for now, thank you again for joining us, and have a wonderful rest of your evening. Bye-bye.